Welcome to Spring LIB.
Okay, in this problem we have a thin flat disk with a radius r naught and a charge q. It has a hole that's half its radius, and we're asked to find the electric potential on the x-axis. So for this problem, we're going to have to find V via integration. So probably our first step is to try to find to get a charge density and integrate that up over the area of this disk. So our charge density sigma, which represents a surface charge density, is going to simply be the total charge Q over the remaining area, factoring in the hole. So that's just the area of a circle, of the whole circle, r naught squared, pi r squared, minus pi 1/2 r naught squared, which will simplify down to 4Q over 3 pi r naught squared. And that's the first step. Now we're going to want to integrate up small little pieces of charge. So we can express a little dq element to be a charge density times an area, little area. We can plug in 4q over 3 pi r naught squared times a 2 pi r dr. So these are going to be little rings of charge for a little area. Oh, and this is a r. And we can integrate these up. So the total potential on the x-axis is going to be the integral. It is simply 1 over 4 pi epsilon naught, integral of little pieces of charge over the distance to that said piece of charge, which for little rings of charge, what's kind of nice is that our r is consistently the same on axis. So we can do this integral in the radius of our disk from r naught over 2 to r naught. And we have 4q over 3 pi r naught squared times our 2 pi r dr element. This is our small charge element. And for the distance from the charge to our point of interest on the x-axis, the distance between them should simply be x squared plus r squared. So we can simplify some stuff down. We can pull some constants out of this integral. We have 2q over 3 epsilon naught pi r naught squared. And our integral becomes this integral, which we can do. Same constants as before. The integral is when evaluated, will become x squared or plus r squared to the 1/2. We evaluate this, of course, at our limits. And it turns out to be 2q over 3 epsilon naught pi r naught squared multiplied by root x squared plus r naught squared minus root x squared plus 1/4 r naught squared. Can box that. That is the electric potential on the axis due to a disk with a hole in it. And that's it.